2 plus, which is also account for the hardness in water. Here you have magnesium hydroxide plus Ca2 plus. Boiling, well, if you want to remove that, you can remove that by boiling. Boiling, it causes the decomposition of the calcium hydrogen trioxocarbonate 4, which is responsible for temporary hardness, thus removing temporary hardness. And that can be done by when you have this compound which is responsible for temporary hardness and you boil it, what will be formed in the process will be CaCO3 as calcium trioxocarbonate 4 plus water, then plus CO2 gas, liquid, solid. This is aqueous. So in this situation now, so when you boil this, you have this, and so that is a way of removing temporary hardness. Distillation, it can also be removed. Hardness can also be removed by distillation. In the laboratory, water is boiled and distilled, leaving behind all the dissolved impurities. Purification of water. The step involved in the purification of water is listed below. Step 1, coagulation, which involves the addition of potash alum to the clump. To clump the dead particles together. What it means is that when you add potash alum, what it does is to bring the dead particles together in form of cluster, and so that they become heavy and dissolve and they can be removed easily. So the substance that is significant there is potash alum. Step 2, bypassing the water in the above step through the filter bed. Yes, filter bed. Then step 3, the water is then treated with some chemicals like chlorine, and the essence of treating it with chlorine is to kill germs. It is also treated with iodine, and what iodine does is to prevent goiter, that is the abnormal enlargement of the thyroid gland. Then fluorine is added to prevent tooth decay. So what it means is that it must be noted that those 3 substances, the chlorine is used to kill germs, iodine is used to prevent goiter, then fluorine is used to prevent tooth decay. Production of distilled water. Distilled water is chemically pure and can be prepared by condensing steam using Lebbe condenser. In the Lebbe condenser, that is very useful in fractional distillation. What it does is that when you eat, the liquid vaporizes, and the vapor is, a Lebbe condenser is connected in a fascinating manner such that the vapor enters it. And because of the fact that the vapor has a temperature, the temperature is very high, so there should be another inlet where water will be passed to counter the vapor. And what it does is to condense it, because condensation is simply a situation whereby vapor is turned to what? Liquid. So what that water that is passed into the inlet to counter that high temperature so that it cools it. And what you have in that situation, the process that is involved in that situation is condensation. And the device that is very significant is what is known as Lebbe condenser. And that's then in that situation you recover the water back. So it is a way of producing distilled water, and the water you will recover in that process is what is known as distilled water. Questions. Water is temporarily hard because it contains dash: A, calcium sulfate; B, magnesium sulfate; C, chlorine; D, calcium hydrogen trioxocarbonate 4. Number 2, a common solvent of sulfur is dash: A, water; B, carbon 4 sulfide; C, alcohol; D, methanol. Then 3, temporary hardness of water is removed by the use of the following except A, boiling; B, use of slaked lime; C, use of sodium trioxocarbonate 4; D, use of alum. Answers to this question. Water is temporarily hard because it contains A, calcium sulfate, no; B, magnesium sulfate, no; C, chlorine; D, calcium hydrogen triisocarbonate 4. It has been explained in the last lesson that calcium hydrogen triisocarbonate 4 is what is responsible for temporary hardness. And the answer to question number 1 is D, as calcium hydrogen triisocarbonate 4. Then question number 2, a common solvent of sulfur is, because of the affinity for a particular solvent, a substance such as sulfur has an affinity for calcium sulfide, the one they call calcium disulfide, or calcium, carbon 4 sulfide or carbon disulfide has affinity. So sulfur has affinity for carbon 4 sulfide or carbon disulfide. So which other solvent do you have there? Water. Sulfur does not have affinity for water because water is polar. Water is a polar solvent. Then alcohol. Alcohol has a bit of polarity and a bit of non-polar. So it is not a suitable solvent for sulfur. Then methanol. Methanol also has a bit of polar, that is the OH there is polar, while the alkyl group there, methanol, the alkyl group, this alkyl group is non-polar, while this is polar. So this one is also has this, and it's not a suitable solvent for sulfur. So the only suitable solvent for sulfur here is carbon disulfide, which is also known as carbon 4 sulfide. And 3, temporary hardness of water is removed by the use of the following, except boiling. By boiling it, you can remove it by boiling. Then 2, use of slaked lime. You can also remove it by use of slaked lime, calcium hydroxide rather. Then use of sodium triisocarbonate 4. Yes, you can also use sodium triisocarbonate 4 to remove temporary hardness. Use of alum. You cannot use alum to remove temporary hardness, because what alum does is, alum is also known as that potash alum, and what it does is used in the process of coagulation to clump that dead together, so it cannot be used to remove temporary hardness. So the only odd answer here is D, which is the use of alum, and that is the answer. Air. Constituent of air. Air is a mixture of gases composed mainly of nitrogen and oxygen with amount of carbon dioxide, noble gases, and water vapor. Percentage composition. The percentage composition of air by volume is 21% of oxygen, 78% of nitrogen, 0.03% of carbon dioxide, 1% of noble gas, while those of water, dust, and other are variable. Flame. Flame are produced when substances burn. It can be defined as where gases combined chemically. Hydrogen. Hydrogen is the first element to be prepared in the pure state. Configuration. Configuration of hydrogen is 1s1. The possible oxidation number of hydrogen is 1 in most of its compounds, except in hydride where it is -1. Isotopes of hydrogen. Isotopes of hydrogen are protium, deuterium, and tritium. Hydrogen is placed in group 1 and period 1 in the periodic table for convenience due to the 1 valence electron it has. Laboratory preparation of hydrogen. Action of zinc on an acid. It produces zinc 2 chloride and hydrogen. So if you want to produce hydrogen in laboratory, it will be action of zinc on hydrochloric acid. So in this situation, you have zinc chloride, aqueous, plus hydrogen gas. So this is one way of producing hydrogen in the laboratory. Then the second way is action of sodium on cold water. By action of sodium on cold water, that is another way of producing it. And in this situation, you have the production of sodium hydroxide, is an alkali, aqueous, plus hydrogen gas. So this is another way of producing it, number 1, and this number 2. Second way of producing. Action of iron on steam. Action of iron on steam is another way of producing hydrogen. So a case whereby you have ion. Ion is Fe on steam. Steam is water in the gaseous state. So in this situation, you have production of Fe2O3 plus hydrogen being produced. So in this situation, you have so this is what you have. So by action of ion on steam, you have the production of hydrogen. Industrial preparation of hydrogen. Hydrogen is produced industrial by passing steam over a red hot coke. A red hot coke at about 1200 degrees Celsius. A mixture of carbon 2 oxide and hydrogen known as the water gas is produced. Water gas is simply a mixture of carbon 2 oxide and hydrogen. Good properties of hydrogen. Hydrogen is colorless, odorless, and tasteless. 2. It is neutral to moist litmus paper. 3. It is relatively insoluble in water. 4. Hydrogen is the lightest substance known. 5. It has a very low boiling point of -253 degrees Celsius. Chemical properties of hydrogen. It reacts with sodium to give sodium hydride. So sodium reacts with hydrogen to give sodium hydride. It reacts with oxygen to form or to give steam. 3. It reacts with chlorine and bromine to produce hydrogen chloride and hydrogen bromide respectively. 4. Reducing action. It is a good reducing agent.